In this video of our final exam for the fall for review, I'm going over the rest of the problems, which are numbers. So I'm going over numbers 27 through 38. I'm going through the rest of the problems in our review. So question 27, what is the domain of this function here? So domain, again, keep in mind, is the x values. So what is the x value where the graph does not exist? So I'm going to keep in mind and that the denominator, right, my x values, well, x can never equal 0. Now, if you're unsure about this and say, well, that means that it's all reals except for 4, how x cannot equal positive 4. Well, let's go through and actually see the graph. Now, there's no hole because there's no common factor to cancel out. So we're looking for the asymptote. So let's go through, and if you were to graph this in Desmos, notice how we have a vertical asymptote here going through. And so notice how our values, the graph is approaching but never reaching this x value here at 4. So that matches what we just said here, but you can see the visual. So again, notice how these values are getting closer and closer, but never reaching 4. So that's why the answer is D. Now 28, we are dividing. Notice how when dividing, we always need to keep change flip. So we're going to keep our first rational expression, but then multiply by the reciprocal, which is now 4x minus 16 over x squared minus 1. Now, as I go through, notice how we have our trinomial. So what numbers multiply to get 12, but add to get negative 13, negative 12, and negative 1. Now, notice here between that binomial, we do have a GCF of 4. So when you take that out, 4 divided by 4 is 1. So 1x minus 4 from that negative 16 here divided by 4, your GCF, over the denominator. Well, that's just x minus 4, so I'm going to bring that down. But then notice how you do have a difference now of 2 perfect squares, because that's the square root of x squared, which is x, and the square root of 1, which is 1. So x plus 1 times x minus 1. Now we can start canceling out the common factors. So I've got x minus 4 and x minus 1. So notice how that will leave you with your final expression, which is 4 times x minus 12 over x plus 1. Now you can distribute the 4 and have 4x minus 48 over x plus 1. Then in question 29, notice how we're subtracting, and subtracting rational or subtracting fractions, you have to have the same denominator. Well, nothing can be factored. They have nothing in common. So that common denominator needs to be x minus 4 times 2x minus 9, where we just multiply them to each other, which means if the first has x minus 4, we need to multiply 5x by 2x minus 9 here. Then 7, we need to multiply by x minus 4. Then remember, we are subtracting. So as we distribute 5x to 2x minus 9, you now have 10x squared minus 45x. Then minus, distribute the 7, so 7x minus 28. Now, because everything is over our common denominator, we're focusing on our numerator. But first, because we're subtracting, distribute negative or negative 1. So this now becomes 10x squared minus 45x minus 7x plus 28. When combining like terms in the numerator, you now have 10x squared, but now minus 52x plus 28 in your numerator. That's why the answer is C. In question 30, you're given that we're given this rational expression here. Which of the following represents the graph that was created? So this is just put this in Desmos graphing calculator. So I'm going to go ahead and make sure that you type that in the graphing calculator. And so it looks like this. So I notice here I have a vertical asymptote going through x is equal to 1. So I'm going to start here at that, where we have a vertical asymptote, that dotted line here, getting closer and closer, but never reaching x is equal to 1. So this graph has x is equal to 1, but B does not. So B is not our answer. C does and B, so from the vertical asymptote. However, if you look at the location of the graph, I could mark off now D. So now looking to C, going back, I notice that I have the coordinate of 2, 0, negative 2, 0. You have that as an x-intercept, a 0, a root. So which of the graphs has that also on their graph? The point, negative 2, 0. Well, notice here, negative 2, 0 isn't even part of the graph. That's why the answer here is C. Question 31 and 32 are solving equations. Before we do, I'm going to notice that if I can factor in my denominator, I'm going to factor. So here I've got a GCF of 6, so 6 times x minus 5. That means in order for these to have a common denominator, 6 times x minus 5, and this only has x minus 5, I need to multiply by 6, the missing factor here. That means once you have the same denominator, I can just set the numerators equal to each other. So this is the same as solving 3x is equal to distribute the 6. So now you have 12x plus 18. Now you're just solving for x. You have a multi-step equation. I'm going to subtract 12x from both sides, and the negative 9x is equal to 18. Then divide by negative 9, and x is equal to negative 2. Now, before I say that's my answer, now remember here, the denominator can't equal 0. That's your extraneous, and x cannot equal 5. So we're good saying that x is equal to negative 2. So here for 32, notice in the denominator, your extraneous, x cannot equal 7. Now here I've got x minus 7, but I have 2 and then another x minus 7. So I notice that means for my denominator, in order to solve, that my denominator needs to be 2 times x minus 7. That's the LCM. That means I need to multiply the first by 2 because that's what's missing here if I only have x minus 7. So if I have 2, that means I multiply by the x minus 7. But I also, because I only have x minus 7 here, need to multiply 5 by 2 as well. Now that all the numerators, we're going to focus here because the denominator now is common. Here, when you distribute the 2, you have 4x minus 18 plus, because we're adding, distribute your x. So now x squared minus 7x is equal to not just 5, right, but 5 times 2, which is 10. Now here, notice on the left side, we do have like terms to combine, but I'm going to also make sure to write in standard form. So x squared minus 3x minus 18 is equal to 10. Then we're solving a quadratic, and quadratics always have to equal 0. So I'm going to subtract 10 now from both sides. The quadratic we're going to solve is x squared minus 3x minus 28. Now, what do factors multiply to get 28 or negative 28 and add to get negative 3? Negative 7 and positive 4, which means x is equal to 7 and negative 4. But go back. We said that 7 is extraneous, which means 7 cannot be a solution. So it's only negative 4. Then the double starred question. So Song solved the equation here and said that there was no solution. Now, notice here, first step from the setup, where Song multiplied by the 3x plus 11 by x minus 4, and multiplied the 4 by here. But remember, if I think about this, right, if I'm going to solve, I need to have a common denominator. I'm not going to multiply here by the two different denominators. So here, if I've got x times x minus 4, but this only has a factor of x minus 4, that means what do I need to multiply by? multiply by the missing factor, which is x. So here now I'm going to solve and distribute. So that becomes 3x squared plus 11x, which is equal to, do we need to do anything with the 4? No, because we already had both factors. So 3x squared plus 11x is now equal to 4. We're solving a quadratic, and quadratics always have to equal 0. So I'm going to subtract 4 from both sides. So the quadratic is 3x squared plus 11x minus 4 is equal to 0. Now here, notice how we do have to do bottoms up. There's no GCF with that 3 here. So x squared plus 11x but minus 12 is equal to 0. Now what factors multiply to get negative 12 and add to get 11? Positive 12 and negative 1. Remember, because of bottoms up, whatever you multiply by, that a value, now make sure to divide. So that's why here you have x plus 4, then times bottoms up 3x minus 1, which is equal to 0. That means that x is equal to negative 4 and positive 1/3. But before, let's go back and check the extraneous. Notice how x cannot equal 0 and positive 4. So we're good saying that both of these are solutions. Now, another way that you could solve this is also cross multiplying. So you wouldn't necessarily multiply 3x plus 11 by x minus 4. You would multiply 3x plus 11 by x times x minus 4. So here, you just need to make sure there's different ways of solving. I just focused on here getting the common denominator and multiplying by the common factor. Question 33. We're adding, so again, when adding rational, you have to have the same denominator. Now I do notice here that I could factor, so what numbers multiply to get negative 22 and add to get negative 9? Negative 11 and positive 2. So notice the first rational expression only has t minus 11, which means what factor is it missing? T plus 2. That's why we're going to multiply 6t by t plus 2 here. So now that we've got that common denominator, we're going to go ahead and distribute. So 6t times t plus 2 is 6t squared plus 12t. And nothing needed with 13t because it was already over the two factors that were needed. So now notice when you combine like terms, 12t plus 13t is 25t. That's why the answer is B. In question 34, there are multiple parts for this scenario. Here we have the expression S of R, where we're focusing on surface area of a cylindrical can, so a cylinder with a specific volume in terms of its radius R. So think of the radius. So remember, right, we're talking about a cylinder here with a radius R. Now she used R so that it could focus on R is your X values, but focused on negative 1 all the way over to 5. So here, remember, domain is your X value. So in this case, the X's are representing the radius. So what would be more appropriate domain? Well, if you think about it, if you're talking about an actual can, let's say, or a soup can, a Coca-Cola can, could you ever have a negative radius? Well, no. So a more appropriate domain for this would be between not necessarily negative 1 and 5, but between 0 and 5. So you could have this as 0 to 5. Now, what is the approximate minimum surface area? So minimum surface area for the can. Remember, the graph represents the surface area. So as I look here, my minimum value is approximately here, which is just below 20, so at about 16 square inches. That is your minimum. Then part C. Part C is asking us to consider the interval shown here. Which interval or intervals is it increasing? into the surface area. So where is the graph itself increasing? So notice how this is focusing on y values. So from y values of 16 to 60. So the y values of, so let me erase this here. So the y values of 16 to 60, which are from here to here. That means we're looking at this entire portion of the graph from 16 to 60. Well, notice how it decreases to the minimum and then increases. So this is both an increase and a decrease. So keep in mind, we only want increase. Then x values from 0 to infinity. So our x values from 0 to infinity. So going on and on. So again, we're looking at the same portion of our graph, but a little bit further. So again, we're increasing and decreasing over this interval. Then this is showing parentheses, but we're used to seeing it also as the bracket, where this is 1 to infinity. So again, we're focusing on x values. So the x values, but starting now at 1 to infinity. So now we're only looking at this portion of our graph, which is increasing. So this is increasing, so 3 is 1. Again, this is the same as our bracket, so this is our x values from negative 60, which is, can't see it, so thinking about it like way over here, to 0. Well, this graph is continuing on, but remember, we're reading this left to right. So reading this left to right, we are decreasing. So this is strictly an interval that is decreasing. Then the last, again, over the x values interval from 2 to 3. So from 2 to 3, notice how we're talking about this portion of the graph, which is also increasing. So here, the intervals of 3 and 5 are increasing. That's why the answer was B. Now in question 35, we're calculating and identifying these pieces. So if you're unsure to identifying what is the whole and the vertical asymptote and the horizontal asymptote, at least start with the graph, right? So I'm going to go to the graph. So this is from a previous problem. So notice how I do have a horizontal asymptote. See, now notice how it's getting closer and closer, but never reaching 1. So we do have a horizontal asymptote. Y is equal to 1. So we're going on and on, but never reaching it. That's our 0 there. Then the vertical asymptote. Well, notice how it's getting closer and closer, but never reaching negative 5 here. So again, notice how it's getting closer and closer, but never reaching negative 5. So right now we're saying we have a horizontal asymptote at y is equal to 1 and vertical asymptote at x is equal to negative 5. Now we can't see where the whole is in Desmos, so we do have to calculate that. But let's check to see if we agree with those pieces where x is equal to negative 5 and the horizontal is y is equal to 1. Remember, horizontal, the degrees are the same, so take the coefficients, which are 1 over 1, which is 1. So far, so good. Then we need to factor. What numbers multiply to get 2 and add to get negative 3, negative 2, and negative 1. Then in the denominator, what factors multiply to get negative 10 and add to get 3? Positive 5 and negative 2. Then remember the common factor, which is x minus 2. That is your whole. Again, remember, this is setting it like it's equal to 0. So that's why it's not negative 2, change the sign. So the x coordinate is positive 2. Then we would cancel that out. And now we're left with x minus 1 over x plus 5. Then if you recall, the vertical asymptote always came from the denominator. Again, still all equal to 0. So x is equal to not positive 5, but negative 5. So that also matched. Then what do we have to do to get the y coordinate of the whole? Well, if x is 2, then substitute x with 2. So this is 2 minus 1 over 2 plus 5, or 1/7. So that is your whole. Then question 36, which statement describes the end behavior? So here as x's are approaching positive infinity. So notice how this portion of the graph is what is going to the right towards positive infinity. Notice how it is going down, but is it going down to negative infinity? Well, no, because notice how we have this asymptote here that it's getting closer and closer to, but never reaching -2. So as x's are approaching positive infinity, our f of x is approaching -2, getting closer and closer, but never reaching it. So I'm going to mark off A and B. Then C, or not C, sorry about that, C or D. So now as x's are approaching negative infinity. So as we're going to the left, right, towards all of our negative, this is our portion of our graph. Now it is going up, but is it going up, 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 up towards positive infinity? No, because again, because of this horizontal asymptote, it's getting closer and closer to, but never reaching the value of -2. That's why the answer is D. Question 37. So what is the horizontal asymptote? So again, remember, look at the degree. Notice how they're both exponents are the same, so we just take the coefficients. Notice in the numerator, we have a coefficient of 1, but in the denominator, a coefficient of 2. So that's why the answer is C. Then question 38. Which of the following statements are true about the intervals? So the graph is decreasing from negative infinity, so negative infinity to 2. So that's your interval. We're talking about from negative infinity to 2 here because we're approaching but never reaching this asymptote of 2. Reading it left to right, what direction are we going? Decreasing, we're going down. So A is one of our answers. Then B, we're talking about from 2 to infinity. So from 2 to infinity. So here's our positive infinity. So again, we're talking about from 2 to infinity. Read it left to right. What direction is our graph going? It's decreasing, not increasing. So B is not an answer. So now let's take a look at C. So from here, so let me erase that. So from 4 to infinity. So from 4 to infinity. We're talking about this portion. What direction is our graph going? It is decreasing. So C is also an answer. Now let's look at from -2 to 2. So from -2 to 2, -2 to 2 here. So this portion of our graph, read it left to right. Notice how the graph is going down, decreasing. So not increasing, decreasing. So D is not an answer. Now let's look at E. From negative infinity to 4. So from negative infinity over here to 4. But notice how the graph never approaches. It doesn't cross over to 4. So it never reaches and goes all the way over to 4. So E is not an answer. So it's only A and C.